Okay, so the box method is obviously called the box method because you literally draw a box. And inside the box, we're going to fill in other boxes. So that's why it's called the box method. The way that the box method works is we're really given two binomials for this particular problem. It doesn't show it, but really what this is this is 3x minus 5, and this is 5x plus 2. And the way that they're doing this is they literally broke them up. So our 3x went into this box, and our negative 5 goes into that box. You okay with that? Over here, 5x and 2. That's all we've done to set this up. And now what we're going to do, have you guys talked about Punnett squares in science yet?
Yeah.
And you have like big P, little p, and you multiply them out? That's all we're going to do here. So literally this box is going to be these two multiplied together. This box is going to be these two multiplied together. What do you think is going to be this one? 3x and the 2. And what do you think is going to be in this one?
2 and negative 5 and 2.
That's it. All right, so check this out. Well, 3x times 5x is going to give me 5x squared.
15. Right?
Yep.
Yeah.
Yep. Good catch, Steven. Good catch. 3x times 2 is going to give me 6x. 5x times a negative 5 is going to give me negative 25x. And negative 5 times 2 is going to give me a negative 10. Are we okay with that? Now, here's the crazy thing though. If we do diagonals, so notice that this writing is in black and my writing's in green. And if I look at this number right here, notice that there's no numbers catty corner to it or diagonal to it. So that means there's no like terms. If I look at this one though, you see how these ones form a nice diagonal? Those are like terms. So that means we have to combine those ones together. And then down here below, again, there's nothing diagonal to it, so it's by itself. You with me on that so far? So if I combine my final answer, it'll be 15x squared minus 19x minus 10. What's up, Carter?
So, never mind.
You sure?
Yes, sir.
Now, if we didn't believe it, we could do the FOIL method here, and it would work out the exact same way. I assure you that it would. I'll just prove it. So let's take 3x minus 5, and we'll take 5x plus 2. I'll multiply these together. 15x squared plus 6x minus 25x minus 10. 15x squared minus 19x minus 10. See how it works out? And again, the reason I'm showing you Ryan, that's the best I can get you with the recording, man. I'm sorry the screen was tilted down. I'll try to move it up shortly, but I can't get any closer with the iPad or it won't record the quality. So I'll try to be a little more descriptive and clear with what I'm saying, but that's the best I can get at the moment, okay? All right. So there's that. Again, this is the same thing. We're still doing binomials times binomials, but we're going to ultimately move into a trinomial times a trinomial. So try this one. I got a box method for you here. 7p minus 2 times 3p minus 4. And what I'd like you to do on that is just try to use the box method and see if you can come up with an answer. So here's how I would write out my box. I wouldn't spend time drawing the whole box if I'm being honest. What I would do is I would just write it out this way. 7p minus 2, 3p minus 4. And I would literally just draw that. You see how that's a little bit easier than trying to draw a full box? That's just my opinion, though. You can do it as detailed as you'd like. So what do I put in this box?
Wait, which one? Oh, no. Sorry.
You're good, man. What about this one?
6 negative.
Negative 6p. How about down here?
Negative 28.
Negative 28p. And then finally in this bottom one, 8, we're all good? All right, and then which two am I gonna have to combine together? JT?
Wouldn't the 28, negative 28 be positive? And then multiply negative by negative?
Positive 7p times negative 4p.
Oh.
If I was doing this one, negative 2 times negative 4 like we did here, then it does become positive. Does that make sense? Which ones am I combining, Colin?
Negative 28p and negative 6.
Yeah, and so my final answer is going to come out to be 21p squared minus 34p plus 8. Cool? All right, awesome. So I think my next two on here are also just binomials. I think we kind of get the gist of how this works. And so I'm going to go ahead and move through this PowerPoint and go ahead and go to a trinomial times a binomial. Are we okay with that? All right, so outside of the PowerPoint, there's a document in your Canvas page. It literally just looks like a worksheet. Again, this is not an assignment or a grade today. This is just some resources for us to practice. And that's kind of what our goal is going to be. I'm going to briefly introduce another idea, but this one I think is so much compounded by things that we've already taught that I don't expect it to be too difficult. So I'm going to do that pretty quick, and then we will go from there. All right, so if I look at like questions 1 through 4, what do you think I want you to do on questions 1 through 4 to solve them? Steven?
Distribute?
That's all I want you to do. So like if I were to look at number 1, I'm going to multiply 6v times 2v. Can anybody tell me what 6v times 2v is going to be, Carter? What is it? 12v squared because I got 2 v's in it. 12v squared. We're all okay with that? And then if I do 6v times 3, that's just going to give me 18v. Okay? Try number 2 for me. I want you to just try number 2 real quick. All right, I got negative 35 minus 56. Negative 35v. Negative 35v minus 56. So we all feel good about distributing that piece. Like I can move past that. All right, so then if I drop down to like questions 5, 6, 7, and 8, we're pretty comfortable using the box method versus FOIL if I gave you that problem. Again, I don't care which one you use, but do you feel decent with it? Okay, then I'm going to go ahead and jump down to a trinomial times a binomial. So if we take a look, we're going to scroll down to, I want to say like question 19. Can you scroll down to 19 for me, please? 19, the amount of wins the Knicks will have this year. All right, so for number 19, we're going to set up the box method. And we're going to do it the exact same way. The only difference is now, instead of having 2 by 2, we're going to have a 3 by 2. And so just watch me write this one out. You don't have to write anything down yet. We're going to do multiple examples, but I want you to see what I'm doing first. First of all, when we're multiplying, does it matter which side goes where? It doesn't. It doesn't matter if your big number goes on top or your small number goes on the side. It doesn't matter. So what I'm going to do is I'm going to write it this way. 4a and 2. And then up top, I'm going to have 6a squared minus a plus 2. So do you notice how I literally just wrote out the polynomials? I didn't do anything crazy. I literally just wrote them out. And then I'm just going to draw a line in between every term to create my box method. Are we We okay with that? Now, I want to specify something to you. I talked to you guys on Tuesday about degree 1 and degree 2. Now, for these specific examples, we might end up going beyond that just for the sake of the example. But on your tests and your assignments, you will never exceed degree 1 or degree 2. Understood? So for today, if we go to a degree 3, just bear with it. Just let it be part of the learning experience. But when I test you, quiz you, give you an assignment, it will only be degrees 1 and 2. Yeah.
So what would degree 3 be?
It means you're going to have an exponent of 3.
That's not much different than exponent of 2.
It won't make much of a difference, no. Okay, so right here, 6 times 4 is what? 24. And how many A's do I have?
3.
1, 2, 3. Okay, we're all good with that? 24 A to the third. Yes, thank you. Thank you, thank you, thank you. Maybe I should get a different color just to kind of make this a little bit clearer for you. So the brown is going to be the actual problem, and then the answers I'll put in green, okay? Okay, what's 6A squared times 2?
12A squared.
12A squared, beautiful. Okay, 4A times negative A is going to be negative 4A squared. 2 times the negative A is negative 2A. 4A times 2 is 8A. And 2 times 2 is? Okay, now I want you to see this last part. This is really important as well. Remember I talked to you about the diagonals a few minutes ago and how they only go with them? Do we agree that there's no other green diagonal to this number? So it's done. What about these ones though? How about these ones? And how about for this number 4? Is there anything? Alright, so if I wanted to write this problem out, here's what it's going to look like. If I want to write out the long way, it's 24 a to the third plus 12a squared minus 4a squared minus 2a plus 8a plus 4. Now based off this, it's already telling me which ones to combine. So 24a to the third stays the same. 12a squared minus 4a squared is going to give me 8a squared. Negative 2a plus 8a gives me 6a plus 4. And that is your final answer. Not too bad, right? Maybe a couple extra steps, but the problem solving itself is pretty simple. Okay? All right, so I need to check my time on my video. Yep, we're getting pretty low on time.